Steam turbines are mechanical devices that convert steam energy into mechanical energy, which can then be used to generate electricity or provide rotational power for various applications. They consist of several key components, each playing a crucial role in their operation. Here are the main parts of a steam turbine with detailed descriptions. 1. Rotor. The rotor is a central component that consists of a shaft and mounted blades. As steam flows over the blades, it causes the rotor to spin, converting thermal energy into mechanical energy. 2. Dot blade assembly impulse blades. These are designed to change the direction of the steam flow, causing the rotor to rotate. They operate on the principle of momentum transfer from the steam to the blades. Reaction blades. These blades generate thrust due to the pressure drop across them, causing steam to expand as it moves through the turbine. They rely on a combination of pressure and velocity changes. 3. Casing. The casing houses the rotor and blade assembly and serves to contain the steam. It is typically made of high-strength materials to withstand the internal pressure and temperature. 4. Nozzle. The nozzle converts the thermal energy of steam into kinetic energy by accelerating the steam jets that impinge on the turbine blades. It regulates the flow of steam into the turbine. 5. Bearings support the rotor and allow it to spin with minimal friction. They are typically lubricated by oil or water depending on the design. 6. Steam inlet and exhaust system. The steam inlet is where high-pressure steam enters the turbine. The exhaust system directs low-pressure steam away from the turbine, usually leading to a condenser where steam is cooled and condensed back into water. 7. Control systems. Modern steam turbines incorporate sophisticated control mechanisms for monitoring and adjusting conditions like steam pressure, temperature, and flow rate to optimize performance and efficiency. 8. Regenerative heating system. Optional. Some turbines are equipped with a regenerative heating system to improve thermal efficiency. This system preheats the feed water using extracted steam from the turbine before it enters the boiler. 9. Governor. The governor regulates the speed of the turbine and ensures it remains within safe operating parameters. It adjusts the steam flow based on the electrical load demand. 10th. Condensate pump. After the steam has passed through the turbine, it is converted back to water. The condensate pump returns this water to the boiler for reuse, making the system efficient. Types of steam turbines. Condensing turbines, designed to maximize efficiency by condensing the exhaust steam. Back pressure. Turbines, used for applications that require process steam. Exhaust steam is not fully condensed. Steam turbine generators, combined with generators to produce electricity. Applications, power generation in thermal power plants. Mechanical drive in industrial processes. Marine propulsion in ships. Maintenance considerations, regular inspections for wear and tear on blades and bearings, monitoring lubrication systems to avoid overheating, cleaning and purging to prevent scale buildup. Understanding the parts and functionality of a steam turbine is essential for its operation, maintenance.
Hey everyone! If you enjoyed this video, please give it a thumbs up, leave a comment below, and don't forget to subscribe to my channel for more content like this. Thanks for watching.
Like what you saw, hit that subscribe button and the notification bell to stay updated on new content.